Okay, so taking a look at the discussion style questions at the end of your lab write-up, we didn't get a chance to go through something like this today. We'll start with number 2, and I'll probably leave you guys to try 3 and 4 on your own if you haven't already. It says 20.0 grams of NaSCN and 25.0 grams of FeNO3 are dissolved in 1.0 times 10 squared milliliters of water, so 100 milliliters of water. And asks us to determine the equilibrium concentration of FeSCN2+. So in order to do this, you need to have a calculated KEQ value from earlier in the lab. I'm going to use just 39 for my KEQ in this case, which is roughly what you'll get depending on how and where you round when you do it earlier, but you'll probably end up with a few more significant figures. That's totally fine. I just want something generally applicable here. I suggest you use whatever value you got to do 3 and 4. But anyway, we are told that 20 grams of NaSCN is dissolved in 100 milliliters of water. So our first goal here is to look at that 20.0 grams of NaSCN and convert that into some number of moles, given that we know something about the molar mass. Specifically, I know that 1 mole of NaSCN is something I can look up and see that it is 81.072 grams. Given that, I can complete this calculation and do 20 divided by 81.072 and come up with 0.24669. Given the 3 sig figs I had going in, 0.247 moles works just fine. So that is my number of moles of NaSCN and therefore of SCN 1 minus. Now I'm dissolving that in 100 milliliters of water. So remember that the concentration of something like the SCN is equal to the amount of the SCN in moles divided by the volume of the solvent. So in this case, that is 0.247 moles dissolved in 100 milliliters, or 0.100 liters, for a total concentration of 2.47 molar SCN. We do a very, very similar calculation for the FeNO3. That is to say that we have given to us 25.0 grams of the FeNO3, and we want to convert that to some number of moles. So given that we can look up our value for 1 mole, and we can see that 1 mole of FeNO3 has a molar mass of 241.86 grams. Then we can figure out 25 divided by 241.86. And that's going to get me 0.103 moles. Now, again, what I'm ultimately interested in here is my concentration of iron 3+, which is my amount of iron 3+ divided by the volume of the solvent. So in this case, 0.103 moles divided by 0.100 liters for a total of 1.03 moles per liter. Awesome. So having determined those concentrations, I can now set up an ice table. I can say, okay, my reaction was Fe3+ combining with SCN- to create the ion in equilibrium FeSCN2+. I know something about initial concentrations, I can figure out something about change and equilibrium. What do I know? I know my initial concentration of iron is 1.03 molar. And I know my initial concentration of Fescn is 2.47 molar. I know that I start with no Fescn, but that I make some amount of it as the reaction goes on, losing my reactants along the way. Because it's a 1-to-1-to-1 ratio, I lose just as much of my reactants as I gain in product. That means at equilibrium, I have 1.03 minus X molar iron, 2.47 minus X molar thiocyanate, and X molar Fescn. So if I take my KEQ expression, which is that KEQ is equal to the concentration of the product, so that is the Fescn2+, divided by the concentration of both reactants, the Fe3+, and the Scn-, then that has to be equal to 39, which is the value, again, that I'm going to use for KEQ. Plugging in the information from my ice table, I get that X over 1.03 minus X, which is my Fe3+, times 2.47 minus X is equal to 39. And at this point, I've got a rational expression that I'm going to rely on technology to deal with. So I'll go to Wolfram or whatever. Maybe I can pull that up on screen there. And I can do that X divided by, and I'll double bracket, 1.03 minus X times 2.47 minus X is equal to 39. And it will think about this rational for a few seconds, and then it'll give me possible values for X. You can see them right here, 1.011 or 122 and 2.5134. This guy's too big. If I plug that in for X, I'll end up without any iron when all is said and done. So let's just use 1.01, keeping my 3 sig figs straight. X equals 1.0. Coming back here, I can substitute in for my X and rewrite 1.01, 1.01, and 1.01. And then finishing up the math there, I get 0.02 molar iron, 1.46 molar Fescn, and 1.01 molar of the fiber. Okay, so that is the equilibrium concentration of Fescn, which is what I was looking for. So that is my answer, and that's what I'm looking for you guys to be able to do. Give it a shot for the next two.